Alright, continuing on with the solutions for the benchmark 2 review. Once we get on to this next section, we got some new things going on. You have the f and the g function on the interval. One is the value of g greater than the value of f. Well, you need to quickly just graph that. The 2x plus 1. Here, if you graph this guy, 2x plus 1 is going to start on 1, goes up by 2 as you go right 1, up by 2, as you go right 1. So we got this pretty straight line here. The 2 to the x minus 1 is going to be increasing like so. Here, hold on. Up 1, over 1, up 2, over 1, up 4. So this one, yeah, you're just going to have to graph it. Sorry, hold on. Alright, so I actually graphed it on my calculator now. If you graph it, use your intersect capabilities on the calculator to get these two values here. And g is the exponential one. Or it's asking where that one's greater. Well, it's greater over here. And on the left side, that's where x is greater than 3, or x is less than negative 0.69. Going on to 16, again, make sure you graph both of those, figure out where they cross. Use your calculator to help you do that. Alright, so I graphed both of those. They intersect when x is 0 and when x is 2.3. And the value of f needs to be greater than the value of g. F is the exponential one. That's the curved one. It's bigger over here on the left side and on the right, but not in the middle. So that'd be where x is less than 0, or x is greater than 2.3. And that brings us to 17. We got these two functions. We need to add them together, so you put down the f function. And then make sure you put these down in parentheses in hopes that you'll make sure you keep all your signs straight. When you're adding them and you have parentheses, they're really not going to do anything. So really you're just combining like terms. 4x plus negative 2x is going to give you just 2x. Negative 6 plus 3 is going to give you negative 3. So that's that one. And you do g minus f, so negative 2x plus 3 minus f, which is 4x minus 6. If you distribute the negative through, you're looking at negative 2x plus 3 minus 4x plus 6. Now just combine like terms. The x's combine, the non-x's combine. You can get negative 6x plus 9. Next part, you need to do f plus g of negative 3. Luckily, we already did f plus g. So now you just need to do 2 times the negative 3 part. And then subtract 3. 2 times negative 3 is negative 6. Minus 3 is going to give you negative 9. And if you want g minus f of 4, look at g minus f, which you already did, and put 4 in for x, so negative 6 times 4 plus 9. Negative 6 times 4 is negative 24. Add 9 is going to give you negative 15. Moving on to 18, f plus g, g minus f, and then we gotta do f over g, f times g. So there's a lot of things, different things on this one. F plus g, f is negative 3x minus 6. G is 2x. Add that, the parentheses don't do anything, so just combine like terms, you'll get negative x minus 6. And that one's good to go. G minus f, well, 2x minus negative 3x minus 6. You have to distribute this negative through. That will give you 2x plus 3x plus 6. When you combine like terms, you get 5x plus 6. And the next part, f over g of 5. Well, f over g is going to be negative 3x minus 6 over 2x. The 5 is going to go where all these x's are. And when you do that, you get negative 3 times 5 minus 6. And then 2 times 5 on bottom. Negative 3 times 5 is negative 15 minus 6 is going to give you negative 21. And 2 times 5 is 10. And that's actually simplified as it's going to be. You can do f times g of negative 3. Write down what f is, which is negative 3x minus 6. You have to times that by g, which is 2x. And you can take this 3 and put it where the x's, the negative 3, and put it where the x's are. If you do that, you're going to get negative 3 times negative 3 minus 6 times 2 times negative 3, which will give me 9 minus 6 times by negative 6. That's a minus there. 9 minus 6 is 3, times negative 6 is negative 18. 19, sequence divided recursively is that. Find the first 4 terms of the sequence. Well, the first term of the sequence is a sub 1, so we're going to start at 9. This says every term is 2 times the previous one. So notice the n plus 1. If you want to get the second term, you have to do 1 plus 2, and that's going to be a 1. So if you want to get the next one, 2 times the previous one plus 3. 2 times the previous one is 18, plus 3 gives me 21. And then you just keep doing that. Times that by 2, add 3 times by 2 gives you 42, add 3 gives you 45. Times that by 2 gives you 90, plus 3 is 93, and you're done. 20, recursively like so. There's your first term of your sequence, negative 400. You need to get the first 4 terms of the sequence. Every term is equal to 1/2 the previous one. So half of that's negative 200, half of that's negative 100, and half of that's negative 50. And there's our first 4 terms. On 21, write an explicit formula to describe sequence from the pattern below. So we're starting at 10, goes up to 15, 20, 25, etc. Here, 10, 15, 20, 25, etc. So our initial value is going to be 10, and we have a common difference. So, sheesh, handwriting sucks on these things. Common difference is going to be just 5, and in 5 each term. So this is arithmetic. Your explicit formula is going to be every term is equal to 5 times n minus 1, and then plus 10. You can simplify that down, 5n minus 5 plus 10, which will give you 5n plus 5. So really any of those is fine there. On 22, write an explicit formula to describe the sequence pattern below. This is timesing by 4 each time, times 4, times 4, times by 4 each time. So this one's geometric, with a common ratio of 4 and an initial value of 4, which is right there. So if you want an explicit formula, it's going to be like this. 4 goes out front, initial value goes out front. Your common ratio goes there, and you do the n minus 1 power. And that one's good to go. 23, write a recursive equation and the explicit equation describe the following sequence. This looks like a pattern of subtracting 5 each time, which makes it arithmetic. Has a common difference of negative 5 and an initial value of 24. So if you want the recursive one, every term is equal to the previous one minus 5. And along with that, you have to say it starts at 24. If you want the explicit one, every term is equal to negative 5 times n minus 1, and then plus 24. And that one's done. Given this, translated vertically 12 units, what's the new y-intercept? Well, this is the equation of a line, which makes this the starting y-intercept. If you go up 12 units, you're looking at negative 11 plus 12 is going to give you 1. So that's the 0.01, by the way. 24, recursive equation and the explicit equation for the sequence here. This is looking like a pattern of dividing by 2 or timesing by 1/2. times by 1/2 times 1/2. So it's halving each time. It's geometric. Your common ratio is 1/2. Your initial value is 600. And so once you have that, you can write your equations. Every term is equal to 1/2 of the previous one. And start at 600. If you want the explicit one, put 600 in front of 1/2 to the n minus 1 power. 26. Given this, translate vertically -8 units. What's the new asymptote? Well, this guy here is an exponential, and this is the asymptote. Y equals 4. And if you shift vertically -8 units, that's just 4 minus the 8, which will give you a -4. So your equation, your new asymptote is y equals -4. And yeah, we'll put the rest of the next value. So 15 through 26.